Hey there, welcome to our geometry journey. I'm Arifa. Today we are diving into one of the most fundamental shapes in mathematics, that is triangles. Now, as I've already explained about the Thales theorem, right? Now we are going to solve this exercise 6.2 and this is the sixth question. Let us solve here. Now this already the figure is given here. In this, A, B and C are the points. Where are these points? Where are this point lying? A is lying on OP, B is lying on OQ and C is lying on OR. Now such that, so this AB is parallel to PQ. Now I'll just show this figure, students. Can you see this? I have colored these triangles in a different colors here, you can see. Now AB is parallel to PQ. So which triangle is this? I'm going to consider POQ. POQ, and I'm going to apply the Thales theorem here, students. Okay. Now can you see in triangle POQ which side is parallel? So AB is parallel to PQ. AB is parallel to PQ. Let me write down this. So now when we know that AB is parallel to PQ, we can say that OA, see this is the Thales theorem. Okay, you can see that this is a triangle. This is a triangle, right? So OA by AP equals to OB by BQ. OA by AP. We need to find out the ratio, students. Ratio. OA by AP equals to OB by BQ. Now similarly, I have written here. So AB is parallel to PQ. Now AC is parallel to PR. Can you see this? This is AC here. AC is parallel to PR. So which triangle is this? You can see that POR. POR is a triangle. And let us find out the ratios here. OC by CR equals to OA by PA, or AP you can say, students. Now I have written here, students. So this equation 1 and equation 2. From equation 1 and equation 2, you can see that both LHS are equal. When these both are equal, obviously these both are equal to each other, right? From 1 and 2, we get that is when both, you can see OA by AP, OA by AP, when both the LHS are equal, RHS are also equal. So I'm going to write here OB. Now you can see that I got OB by BQ equals to OC by CR. You can see this. OB by BQ equals to OC by CR, which is a triangle, that is QOR. QOR. So we have got the ratios, students. We have got the ratios. So when we got the ratios, obviously the parallel sides, you can see that BC is parallel to QR. BC is parallel to QR. It is already proved here, right, students? So I hope this is clear to you all, students, right? From this equation 3, what is the equation we got here? Here OB by BQ equals to OC by CR. OC by CR. So I got this triangle, which is a triangle. QOR is a triangle, and we got the ratios, students. When I got the ratios, so therefore I can say that BC equals to QR, right, students? I hope this is clear to you all. Now you can see that there's a figure here. Now we have to apply the theorem, that is Thales theorem, and prove that the line which is drawn through the midpoint, this is a midpoint D. So line which is drawn, okay, through the midpoint of one side, this is the midpoint of this side, that is AB is a side, and the line is also parallel to the another side, and this E is touching AC. That means E is bisecting AC. We have to prove that. Okay, when I said that E is bisecting AC, bisecting means, that means I have to prove that E is the midpoint of AC, students. Okay, now come on, we know from the question that D is a midpoint. D is a midpoint. It is already been given. D is a midpoint of AB, which is given already, which is given midpoint. That I can say that AD equals to BD, correct? Now if I take that BD down, so 1 is left over there. Okay students. Now after that I can use a triangle. In triangle ABC, in this triangle ABC, DE is parallel to BC. When I say that these both are parallel, I can use a Thales theorem here, that is AD by BD. AD by BD equals to AE by CE. Okay, but we know that is AD by BD is nothing but 1. I can write 1 upon 1 equals to AE by CE. Let me do cross multiplication. I am going to get AE equals to CE. We got that is AE is equal to CE. That means E is bisecting the third side. Therefore, I can say that E is the midpoint. E is the midpoint of AC, students. Okay, I hope this is clear to you all. Come on, let's solve next question. Now you can see, using theorem, we have to prove that line joining the midpoints. This is a line which is joining the midpoints. Which are those midpoints? That is D and D. Of any two sides. I have used the sides, that is AB and AC. Is parallel to the third side. We have to prove that this line is parallel to third side. We have to prove. And what is given? That this is a midpoint which is, okay, this is a midpoint which is lying on the side AB, and E is lying on AC. I can take here, okay, D is the midpoint. D is the midpoint of AB. When this is midpoint, I can say that AD equals to BD. AD equals to BD. That is, I can write AD by BD equals to 1. Now, if I take E is the midpoint of, E is the midpoint of side AC. When E is the midpoint of AC, I can write that AE is equal to CE. Now, AE upon CE equals to 1. Okay. Now, as you can see, this is 1 and this is 2. From 1 and 2, you can see both RHS are equals to 1. Then LHS are equal to each other. Okay. I can say from 1 and 2, we get, that is AD upon BD equals to AE upon CE, students. So AD by BD equals to AE by CE. Therefore, we can say that DE is parallel to BC in triangle ABC. I hope this is clear to you all, students. Come on, let's solve next question. Here ABCD is a trapezium, okay, in which AB is parallel to CD. So these are parallel sides of the trapezium, students. These are non-parallel sides. Now there are diagonals here, that is AC and BD. They are intersecting at the point O. We have to show that AO by BO equals to CO by DO. We have to show. Now, anything can be done. We cannot use a Thales theorem until unless we have got a parallel side. Okay. So let me draw OE. From O, let us draw, students. Okay, students. Now when I have drawn OE from O, that means this is parallel to CD and AB as well. Okay, so when I've used that DC or CD when I've taken, so this will become a base and this is a triangle. This is a triangle, students. This will be a triangle, and one more triangle is, see, this is the parallel side, that is AB. So this one will become a triangle, students, right? Now as you can see, I've colored this. That is OE is parallel to CD. That means this is the base of the triangle. I'm going to apply the Thales theorem. That is, let me first apply the triangle here. Let us take the triangle here. That is, in triangle ADC, that is OE is parallel to the base, that is CD. This is the base CD. Let me apply the Thales theorem here. Okay, AE by ED equals to AO by CO. Okay, students, that is AE by ED equals to AO by CO. I got here. So this is a triangle. I am going to consider another triangle, that is EO is parallel to the base, that is AB, it is parallel. So when these both are parallel, I can say that AE by ED equals to BO by DO. Okay, students, see, we can apply the Thales theorem here. AE by, as this OE is parallel to the side AB, I can say AE by ED equals to BO by OD. In triangle ABD, so this is parallel to the base. EO is parallel to AB. Okay, so when it is parallel, I can say that AE by ED equals to BO by DO, BO by DO. This is 2. From 1 and 2, you can observe that LHS, both the LHS are equal, then obviously RHS are also equal, right? From 1 and 2, we get AO by CO equals to BO by DO. Now here, see, AO by BO, just we'll interchange this. So AO by BO equals to, we'll shift that side, that is CO by DO. I hope this is clear to you all, students. The diagonals of a quadrilateral. Quadrilateral is nothing but the four-sided figure is called as quadrilateral. Now this is a quadrilateral ABCD and the diagonals are intersecting at the point O. Okay, such that we can say AO by OB equals to CO by OD. We have to show that ABCD is a trapezium. We have to prove that ABCD is a trapezium, students. Now, to prove that, I need to draw OE. Okay, we need to draw OE through O such that it is parallel to CD and AB as well. Okay, draw OE from O. Okay, so now we can say that OE is parallel to AB. OE is parallel to AB. Okay, now in the triangle, let me consider the triangle ABD. ABD is a triangle. So when this is a triangle, this is parallel to the side AB. So EO is parallel to AB, students. So when this is parallel, I can say that AE by ED equals to BO by OD. AE by ED equals to BO by OD. BO by OD. Okay, this is one, let me consider. But this is already given. AO by BO equals to CO by DO. It's already given, students. It's already given. Let me interchange this. Okay, now AO by CO equals to BO by DO, I can say. But BO by DO is nothing but AO by CO. Okay, so is this clear, students? When both the LHS, when both the RHS are equal, LHS are also equal. Let me consider this as 2. From 1 and 2, when both the RHS are equal, I can say LH is also equal. AE by AD equals to AO by CO. See here, AE by ED equals to AO by CO. AO by CO. That means this is parallel to this side. I finally got that OE is parallel to CD. Therefore, EO or OE, you can say parallel to CD, students. CD. Okay. Therefore, we know that AB is parallel to OE and OE is also parallel to CD. AB is parallel to OE and is also parallel to CD as well. Therefore, I can say AB is parallel to CD, and therefore we can say ABCD is a trapezium. Guys, this one we have proved. I hope this is clear to you all, students.